Hey, it's Paul Seaver from Palm Beach Springs Water Company. And what I'm doing is part 2 to a stability test for chlorOrgano in an open container subject to evaporation over a long period of time. So part 1, the original container is right here in the measurement for evaporation. So this is about a month in the making now. It started out at 150 ml and now it's less than 50 ml. And so what I got here is I got a 2,000 part per million chlorine and a 750 part per million hydrogen peroxide test strip right here. Okay, so this is take 3. Learn by your mistakes. I got them separated because if they're too close together, the colors bleed over. So I'm going to take this and I'm going to put it in here where I can keep them upright. This one was 1,500 part per million fresh out of the tank last time. It was filled to the top of the blue line. Now it's at the bottom of the blue line. So it should show stronger from that evaporation. Now I don't know because I'm a little mixed up now because of the hurricane. I think this is about a week or so ago, but it'll show on the first test what the date was. Now this one, I just poured this morning out of the drum that I've been using since the first one was made. This is the same solution that made this one right here, but this has no evaporation because it's in a sealed container. Even though I'm using it, it's not subject to evaporation. Okay, oh, I got that strip turned backwards. All right, so when we first started out, we were at 1,500 part per million, which is this color right here. Okay, now taking this one out, you can see we are far stronger than this is hard to do. Far stronger than the strips will measure. So we're way over 2,000 part per million. Way stronger than these strips are going to measure for hydrogen peroxide. So we're over 750 part per million. So that's a given. Okay? So we'll take these, put them to the side for a moment. Now this one started at 1,500 part per million, but now it's too hard to hold it up there, but oops. Well, we could do the peroxide first. The peroxide's definitely stronger than 750. And the chlorine is definitely stronger than 1,500. You got to get these things right to see the colors. Okay? It's up over 2,000 actually. Okay? So that's fantastic. Now, the stuff that we just made, you can see, is closer. Got to be a trickster to be able to do this. 750 part per million. It's closer to that color now. It's just a little bit stronger. And then on the chlorine, you can see we're almost dead nuts on 1,500. Maybe just right there, you know. I'd say that's dead nuts color. So, this is what we started out with in this little jug. Look at the difference now. That's crazy difference right there. The lighter the color, the stronger it is. There just isn't no color match for that. And then if you turn it around to hydrogen peroxide, the darker it is, the stronger it is. So as it evaporates, it doesn't destabilize. It just concentrates more. You have to put something in there to destabilize it. There's just too much electrical power. Now, if you take, let me get rid of this one. Oh, no, that's the one we want. And get rid of the super concentrate. Okay? So we take the ready to go, well, not ready to go, what I took out of my drum undisturbed, and you check it against the hydrogen peroxide. Here again, you know, you're talking darker. Man, it's hard to do this. You can see it's darker. And then when you do the chlorine, same thing, it's lighter. Okay? So you're concentrating. Now, when you take the one that's slightly evaporated and you put it up against the one that's almost gone, look at the difference. I wish I would have thought better. I would have put them on the right side of each other. But you can see, it don't take a brainiac. Insane. Nobody has a stability like that in a product. Nobody. And the beauty of this is that you don't have to have ORP or pH to deliver the chlorine. It's all delivered by ionic product. Ionic product allows it to be delivered through an aquaporin. Hang on a second. Remember, you have to be able to break stuff up into single elements or whatever, particles, elements, whatever, single gases in order to deliver through an aquaporin, right? And plus it has to have the right electrical charge. So, if no matter what, just imagine this is the chlorine gases. They're all dissolved in single molecules. And so that's where the delivery comes from. So, and the proof is in the product when, you know, especially in water treatment, you know, it turns water crystal clear because the hydrogen peroxide, of course, at a higher pH. All these pHs are higher. I did a pH when I was doing membrane separation on the chlorOrgano, and it didn't come out right. And then, you know, sometimes when I'm doing videos, I'm not necessarily thinking. And the reason why is because I used the container for the ultra low ahead of time, and it was still embedded in the plastic. Super strong stuff. Okay, so here's fresh out of my container, and we're looking at, got to give it a second. And then also we'll do an ORP on it. Because my ORPs were off too. It's still going up. Got to give it a minute. I need a haircut. So our ORPs right now, even in concentrate, well, hang on, they're still calibrating. Well, they're at about 760. So as long as we're below 800, you know, hyperchlorous acid is up like 950 or so. So you have to be over 800 for it to be oxidizing. And we're on 760-ish, 770. And then so far we're at 8.47. But this meter I already know is 1 point pH off to the low. And we're supposed to be up at about 9.8 pH. So if you put the correction in here, you know, we're right there where we're supposed to be. But 9.8 is really 2,000 part per million. This is 1,500 part per million. So as you drop in part per million, you also drop in pH. The pH isn't really a measure of pH in this, which is kind of odd, but it's just a measure of the chlorine strength. So how much chlorine you got stored. So anyway, we're at 9.6 pH right now. And we're at 777 on the ORP. I know the ORP is pretty gosh darn accurate because I can check it between ultra high and ultra low. And I can check the pH that way too. That's why I know the pH meter's off by 1.0 pH, because yesterday when I'm checking the ultra high, ultra low. So there you have it. So that's chlorOrgano. Some pretty special stuff. I wish I had a way to measure more things, that are in there, but you know, I don't have those kind of tools to measure gases. I can only measure what you can measure with a strip. I can't even measure the ozone in there, but it's a given there's ozone in there because we're splitting molecules of H2O. So you're getting ozone and you're getting hydrogen. But in this case, the way it's done is the chlorine is the dominant force in there. So that's why the chlorine will always be the highest reading. But anyway, that's it. It's pretty impressive stuff. You know, the equipment is not new. It's been around. My machine right here is an old timer. It was built in 1999. 1999. This stuff has been around for 25 years, and nobody ever ventured in to the alkaline range. They only used it for the acidic range. So this specific generator will build a hypochlorous acid, but just as in any way to produce hypochlorous acid in a neutral environment, you're going to have to use hydrochloric acid to drop the pH down. Now, with these machines right here, I don't have to do that. And with my big machine right there, I don't have to do that because that's not what they're designed for. But the hypochlorous acid generator cannot make this. It only makes hypochlorous acid. It can't make anything in this range because you have to have power on both sides. So this is very unique, and I mean, you just can't beat it. And in water treatment, it's super, super, super strong because it's charged with 10,000 MA, 10,000 times the power of chemical reaction. So you know it's strong. You don't have to have it at the same part per million. So that's chlorOrgano, and that's how stable it is. And I'm going to continue to let these dry. We're going to do a part 3. We're going to do a part 4 because I want it to dry up to salts. Once it dries up to salts, I want to see what happens. Is that the same as like powdered? I don't know. We're going to see what happens anyway. What does that salt turn into? That's what I want to know. And nobody can tell me because ain't nobody's ever done it. That's the funny part about it. This stuff been around 25 years, and nobody went above 7 pH with it. They never thought about it. They didn't have a use for it. That's not what they prepared the machine for. So it is what it is. And the other thing is you could do a lot of other stuff with it too. I can make super high alkaline stuff. I can make super low acidic stuff. It just all depends, but that's not what I do. I stay in the neutral range. I try to do everything without using electrolytes. That's my whole target. So anyway, that's it. chlorOrgano, my baby. It's awesome stuff. If you think anything I do in my videos is trickery, no problem. I'll give you my address. Bring $1,000 in cash with you. I'll put $2,000 down on it. I'll give you 2-to-1 odds that I'm telling the truth. This is all factual. There's no smoke and mirrors, and there's no bullshit. There you go. Paul always has to drop something somewhere in one of his videos. Got it out of my system. Adios.